and welcome to my new video. Today we discuss about linear partial differential equation with constant coefficient. Before we discuss all the partial differential equation for not for higher order. Now this is for linear partial differential equation with constant coefficient for higher order. There are two types of linear equation. One is homogeneous, other is non-homogeneous. The equations are standard form of this a0, a1, a2, a3 all are the constant. This is the partial differential equation with z is the dependent variable on x and y, and x and y are the independent variables. So del n z by del x and a1 del n by del z, now x to the power n minus 1 and del y, and so on. Similarly, other coefficient of z is n minus 1, b0 del n minus 1 del xn plus b2 n minus 1 del n2 and so on, equal to right hand side is the function of x and y. This equation is the standard form of linear partial differential equation. Some examples are given there. Previously I tell you these are the two types of equation, homogeneous and non-homogeneous. These are the example of homogeneous differential equation, homogeneous linear partial differential equation with constant coefficient. Why we say homogeneous? Because if you see in each of the term the derivative power is the same. Whole equation order and degree is 2. Del 2 by del x square, del 2 del x del y, del 2z del y square. In here also del 3 by del x cube, del 3z by del x square del y, and so on. Right hand side the function of sine x and e to the power x plus 2y, either function of x or function of x and y. No z is there. So these two are the example of homogeneous linear partial differential equation of constant coefficient. Next I write some example of non-homogeneous. So if I write, question is del 2z upon del x minus del 2z upon del y square equal to e to the power x, sorry, del z by del x. This question number 1. Question number 2, del 2z upon del x square to z by del x del y square plus 4 del z by del y plus z equal to sine x plus y. See, these two are the example of non-homogeneous. Why I say non-homogeneous? If you really see the previous examples, every term in the equation having the same power. Now here this is derivative of first order, this is derivative of second order. So this is non-homogeneous. Similarly, there also these three are for second derivative. This is one derivative and this is no derivative here. So these types of equation are called non-homogeneous. So non-homogeneous linear partial differential equation having different for solution methods and for homogeneous different solution methods. So first we discuss homogeneous linear partial differential equation with constant coefficient. How to solve homogeneous linear partial differential equation. This homogeneous, we can discuss the homogeneous only. Homogeneous, if I write standard form a0 d to the power n, if I say here del by del x and del by del y is d and this is d dash. Del by del y we can say d dash and del by del z x is we can say d. Similarly, if we want to write del 2 by del x del y, that is d dash, del 2 by del x del y, so this is d dash. Clear? So now I write in this notation a0 dn plus a1 dn minus 1 d plus and so on an d dash n plus z equal to f of xy. Right hand side is the function of x and y, where a0, a1, a2, a3 all are the constant. So we can rewrite it if we can say this is the phi, function is phi. Phi of d dash equal to f of x. So this is the standard form of homogeneous linear partial differential equation with constant coefficient. Now for this homogeneous partial differential, this is higher order. You already learned in simple differential equation how to solve higher order differential equation. Means if you have higher order differential equation, you see that higher order differential equation we can solve with two parts. One is complementary function, second is particular integral. So first we have to find out CF, complementary function, then partial integral, then both together is give the complete solution. So for this case also same, complete solution is given by Z equal to CF plus Pi, particular integral plus complementary function. So similarly, if we follow the simple differential equation and now go for partial, difference is only there is only two variable, one is dependent, one is independent. Now in this case we discuss two dependent, two independent variable and one dependent variable Z. So little bit difference in complementary writing of complementary function and particular integral, but you must remember those things. If you remember those things, you can easily follow how to find out these complementary function and particular integral. So now I discuss the first how to write the complementary function for if roots are same, if roots are different, like that. You remember if roots are repeated. So first is the complementary function of second order partial differential equation. If we have a0 d square plus a1 d dash plus a2 d dash square equal to 0. If second order partial differential equation is there, for complementary function we replace d equal to m and d dash equal to 1. When you replace d equal to m and d dash equal to 1, your equation gives one quadratic equation in m. So you can easily find out the roots after replacing, find roots of equation, roots of that given quadratic equation. Now complementary function is depend on the roots, which type of roots are coming, we have to write on that way. First one is roots are real and different, real and different. If roots are real and different, for example, our roots are, because this is equation in m, our roots are m1 and m2, correct? If our equation have roots m1 and m2, so I give you the solution how we write the roots for complementary function for real and different roots. So for this, if we have m1 and m2, we can write f1 complementary function is equal to f1 y plus m1x plus f2 y plus m2x. It means we are writing complementary function like this. If we have n order differential equation, we substitute n order equation, then the general complementary function is, I write in the general form, fi y plus mi x, correct? So f1, f2, f3, f4 and so on. So these are the types of complementary function. First type, if roots are real and different. Next, if roots are real but repeat. If roots are real and repeat, in that case, for real and repeat root, you can write same. If our roots are m1 comma m1, then f1 y1 plus m1x plus f2 there is also m1, but we have to introduce 1x here. In that, if real differential equation higher order, you can see we can write e to the power ax plus e to the power bx and so on. If we have real and repeat root, then you remember how to write. Similarly, we introduce one variable x here. So f1 y plus m1x plus x, f2 y plus m1x. Clear? So this is the way to write complementary function for repeat root. Now I show you one example how to write the complementary function, so you can better understand for homogeneous equation. First we write only complementary function, after we go for particular integral. If I have a question del 2z upon del x square minus 4 del 2z upon del x del y plus 4 del 2z upon del y square equal to 0. I don't have right hand side. If right hand side is not exist, it means our particular integral is 0, and a given solution, complete solution is given by complementary function only. Z equal to complementary function. So we have to find out the complementary function. I can write same, remember del by del x is equal to d, del by del y equal to d dash. So if I write in d and d dash, this is d square minus 4d dash plus 4d dash square equal to 0. For complementary function, our auxiliary equation we have to write in with the help, put d equal to m and d dash equal to 1. Clear? If I substitute here, this will become m square minus 4m plus 4 equal to 0. Clear? So our equation become m square plus 4 minus 4m plus 4 equal to 0. It means this is given root is m minus 2 whole square. Clear? This is roots are m is equal to 2 comma 2. Real and repeat. So for real and repeat root, I can write the complementary function equal to f1 y plus m1. m1 is 2x plus x, f2 y plus 2x. So this is our z complete solution also for given equation if right hand side is 0. If right hand side is having some value, we have to find out the particular integral and then add it here. So this is the solution. Next, if we have one more example, same type, if we have only which type of some repeat root, some not repeat root, how we write, you can better understand how to write. Next I give you one small example on same. So then we go for the del 3 del dash 2 plus del 2 del dash 3 z equal to 0. See, this is the order of 5 equation, means homogeneous equation. So for homogeneous equation we have to find out CF PI. PI is 0. For CF we write the auxiliary equation. Auxiliary equation d is equal to m, d dash equal to 1. So our equation becomes m cube plus m square equal to 0. Clear? M cube plus m square equal to 0. It means we have to find root m square, m plus 1 equal to 0. Clear? So with this we have 3 roots because it is cubic equation. M equal to minus 1, and with this m square is 0 comma 0. 0 2 times means we have one pair of repeat root and one is different real root. So now how I write? See, z, I write z because its solution is complementary function only. Z f1 y plus m1x, plus is 1, m1 is minus of 1x, plus f2 y plus m2, m2 is 0, 0x is 0, plus x, f3y. So solution is this: f1 y minus x plus f2 y plus x f3 yx. Clear? But in this case we can see our given equation is in order of 5. When we replace d dash equal to 1, our equation become order of 3. We will get 3 roots. So we will write only 3 part of complementary function. But what is the order of the given equation? You have to find that much root. So 2 roots are missing. For that, if any equation have a0, if any equation have a0 equal to 0, because in this case a0 del nz by del xn means a0 is there, then you can find all the roots. If that is not represent like this, then in this case we can rewrite again. We can take square z equal to 0. D dash square means del 2z by del y square equal to 0. Now if we finally find out, if we integrate, we can find out the two function. Then with this, its roots are 0 comma 0. So we can write its roots are in terms of, because this is in terms of y, so we can write f4x roots are 0 plus repeat roots. So y f5x. Clear? So because of this term, we can write these two parts also here. So our complete solution is this plus this. Our complete solution of z is given by this. So that is the complementary function. If a0 is equal to 0, you have to take out the common part, and then with this, or in easy way you can think about it, how we can find. You just substitute, this is the y, del 2y by del 2z by del y square. If we put d dash equal to m, then what is our auxiliary equation in this case? In this case, our auxiliary equation is m square equal to 0. M square equal to 0 gives two roots, m equal to 0 comma 0. So now because of this is y, so we can write in terms of x plus, what is the method? F of x plus my. Clear? But these roots are 0, so f of x plus 0y, so y goes 0, so f of x. Repeat, so front income y, f5 of x. Similarly, in this case x come, in y case, d dash case, y come in front. So that is the complementary function. Now I will discuss PI for linear homogeneous partial differential equation. So we go for how to find particular integral in different case. PI means particular integral of our equation is d comma d dash phi of d comma d dash, or we can say d comma d dash z is equal to f of x comma y. Clear? So first case, if our equation in terms of fxy, right hand side, in power of x to the power m, y to the power m. Same. In previous, if you think how to write, if we our function right hand side in x to the power m, we can expand it with the binomial powers. So here also we can expanding into infinite series of ascending power of either d or d dash. We can expand this into ascending power series of either d or d dash. Clear? What is the expansion? If because of, we can see m is the power of x. If m is greater than n, we can expand in d. If n is greater than m, then we can expand in d dash. Whatever the greater power, we can expand with the help of that. Clear? And after that, same method which is we follow in the previous differential equation. If we have d, then we have to differentiate with respect to x. If we have d dash means differentiate with respect to y. If we have 1 by d means integrate with respect to x. If we have 1 by d dash means integrate with respect to y. Clear? Next, if our function is in terms of sine or cosine. If our function is sine of ax plus by or cosine of ax plus by. So if our function is in terms of sine or cosine, so we can write for pi, I write 1 upon 5 d square d dash and d dash square of sine ax plus by, or I can say cos ax plus by. Same like differential equation, you compare. Here we substitute d square is equal to minus a square. Same here, d square is equal to minus a square d dash. d dash is minus of a b and d dash square is minus of b square. Only these terms can replace with these values. Simple single term. If we have only d term, then we can't able to replace it. So only this term we can replace it and we will get easily our solution. Next is the third. If our function is given in the exponential power of x and y, means fxy is e to the power ax plus by. So for this same, if we have e to the power ax, d dash, we can, for if we have for d, replace a, d dash replace with b. Clear? And then we will get the solution. If we have d dash, we have to replace with a into b. So these are the some important solution for particular integral. Now I give you the one formula, general formula. If these cases are failed or we will get denominator is 0 in case of pi, then we can't able to use these types of shortcuts. We can go for the general formula for this. For general formula of this, I will give you whatever your pi f, we can write 1 upon d minus m d dash of f of x comma y. We can write it integral of what is f x, y is, we can replace c plus mx dx, y is c plus mx. So you can replace y here and then integrate with respect to x. At the end you again replace c with y. You will get the solution. This we can repeat again and again how many times we want, because this is the general integrable form of any given particular integral right hand side function. So I can now show you some examples on all 1 methods, so you can better understand how to find the particular integral. So now I go for the examples. Question is del 2z upon del x square minus 4 del 2z upon del x del y plus 4 del 2z upon del y square equal to e to the power 2x plus y. Simple. Solution is, first we have to find out complementary function. For complementary function, if I write d square minus 4d d dash plus 4d dash square is equal to e to the power 2x plus y. AE, for AE, put m is d and d dash equal to 1. See, A0 is 1, not 0. So we can find easily to quadratic equation is m square minus 4m plus 4, same. So for this case our roots are m equal to 2 comma 2. So our complementary function I can write f1y plus 2x plus x, f2y plus 2x. Clear? So this is complementary function. Now I go for particular integral. For particular integral, if I go 1 pi 1 upon d, what is this? D minus 2d dash whole square, clear, of e to the power 2x plus y. Clear? This is the d minus 2d dash whole square of this. Now if I put here a is 2 and b is 1. So if I put d equal to 2 and d dash equal to 1, then 2 minus 2, it becomes 0. Clear? So that rules fail. Means if denominator becomes 0, you can't apply this rule. You can go for the general solution of whatever I teach you last one. General equation for this. So now I can use general. So for pi, first there are two parts. See, 1 upon d minus 2d dash into d minus 2d dash of e to the power 2x plus y. Now we can write. So now we can use only this one part. We can say this is our u. So second part is 1 upon d minus 2 d dash into u, whatever u will become after solution. So I find u first. U is 1 upon d minus 2d dash of e to the power 2x plus y is equal to integration of y is what? Y is c plus m. M is 2x. So I can write 2x plus, at the place of y I write, you cancel, e to the power c is constant. Integration of dx is x e to the power c. E to the power c, when you substitute, c is y plus 2x. Y plus 2x. Clear? So this is our u. U, now you replace here. I can replace u here. 1 upon x e to the power y plus 2x. Now again same method, if we can use this x e to the power y plus 2x here. So again in this case, what is my y? Same, integration of x e to the power 2x, my y is same, plus c minus 2x dx. 2x cancel, e to the power c is the constant, coming outside, integration of x is x square by 2, correct. So this becomes c into x square by 2, correct. So now replace c is y plus 2x. So our pi is given by x square by 2 e to the power 2x plus of y. So now what is my complete solution? Complete solution is CF plus PI. I rewrite here complete solution. Z is equal to, this is my complementary function, plus Pi x square by 2 e to the power 2x plus y. this is my complete solution for given equation. So it's not too difficult. If you know all the rules, you can go step by step. You will easily solve this. Next, I discuss one more example when the particular integral given in the power of x to the power m and y to the power n. After that, we will discuss one example on sin x plus y or cos in terms of sin and y given. So with this we can discuss all the form of given equation. Clear? So now if our given particular integral in power of x and y. So I write the question d dash square z equal to x square y. See, x to m, y to the power n. So n is 1. Sorry. Now solution. First one, complementary function. Complementary function we can write m square minus 1 is equal to 0. Our root is m square equal to 1. So m is plus minus 1. So CF you can easily write what? Yes, f1 y plus x plus f2 y minus x. Clear? C1 is simple. You can find out and put it one way. Then we go for the particular integral. So after at the end we can rewrite for pi. What is this? 1 upon d square minus d dash square x to the power 2 y to the power 1. Clear? Now if m is greater than n, here see 2 is greater than, I can write in form m is greater than n, then we can expand in terms of d. Clear? So you can take out 1 upon d square. So it becomes see 1 minus d dash upon square upon d square to the power minus 1. Clear? Of x square y. Now you remember the binomial expansion, 1 minus x to the power minus 1. So 1 plus x square plus x cube and so on. If both are minus, then everywhere is the plus. This is the general expansion. With this help we can go 1 upon d square. This will become 1 plus x. This is our x. So d dash square upon d square plus x square plus x cube, d dash square of square is d4 and so on of x square y. Now we operate each term with this. So next step, 1 upon d square is outside. It will be operated at the end. 1 upon d means integration. Correct. So this first term is x square y plus this is d dash square upon d square of x square y. Next term d dash means derivative of y 4 times. That will become 0. Here also d dash square means d by dy of y. 1 time and then 2 times. When 1 times you derivate, this term becomes 1 constant. Next time it will go 0. So you will get only this term. All other are 0. So 1 by d square x square y. 1 by d means integration with respect to x, treating y as constant. So now we can integrate with respect to x. Clear? So 1 by d 1 time and 1 by d is x square y dx. So it will give 1 by d, x square gives, y is coming outside, x square is x cube by 3. Clear? X cube by 3 into y. Now again this 1 by d means you can integrate one more time with respect to x. So y by 3 is outside, integration of x cube dx. It gives y by 3, x cube is x4 by 4. Clear? So this is our pi. Now our complete solution is z equal to cf plus pi is given by, our cf is f1 y plus x plus f2 y minus x plus x4 y upon 12. This is the solution of given question. Now you understand how to expand in the power of x or y. And you remember each and every term, whatever the given. If d means del by del x, only differentiate with respect to x, y treating as constant. D dash is del by del y. D 1 by d is integration with respect to x. 1 by d dash is integration with respect to y. So you must remember, and then you operate each and every sign. If you know, you remember, you can easily solve these type of question.